So we want to enter this data and see what we can do with the data. So this is the data. We have age, we have height. I want to look at it by entering the data. So I can start with a comment and say enter our data. Okay. Now, before I even enter the data, so there's one thing we have to know here. Earlier, as we were looking at the arithmetic operations, we were just using the functions without assigning the outputs to any objects. So what we want to do is change a few things here, like this. For A, for this addition, we want to assign, let's say, to A 1 plus the same thing, 1 plus what? 2. Let me space out to make it readable. And once I do that, I shouldn't have an output, because what I've done is that I have stored the output into A. So to see the output, I need to call out A. We can do that for B, as for any object, or if you like B1. Let's use different notations. And that should give us nothing, but the answer is stored in B1. So to see the answer, we can call out B1. And that happens with any data set or any operation. It can be a very huge data set, which is even the more reason you need to do that, because they want to put the whole data set on the screen. So that's what we want to do with this data that we are given. So the first one is age. So we can assign it to age as well. We don't have to. You can use a different name, but you can use age as well, just to remember. So we need to create a vector of the ages. So I'm entering the data as we saw it earlier. 6541 51 35 32 and 36. So always you need to run your line when you finish to make sure it worked. So it does work. There's no error. The next one is height, right? I think it said weight in the description. It was weight, so let's use weight instead to be consistent. So that's another vector of 151.76 is 139.8 136.44. It does not matter exactly what the numbers are anyway. 156.85. We have 164.10 plus 148.28. 120.22, and I think there's the last one is 90.47. So that should also work. That's fine. We can leave it at that, or we can create a numbering for that as the SN. And here I want to use a sequence instead of entering the numbers. So this function will give you a sequence. So the good thing with RStudio is that any function that you have, if you have to use it, it will give you an explanation. So if you put the sequence here, you realize that saying generate regular sequences. Okay. And it works like this. You start, let's say, beginning, comma, end, and it says by. So this will be begin. begin. So let me put a quotation here, a comment here to indicate. So what's happening is that you are starting with, say, 1, you are going to end at 8. We said there are 8, and we are increasing by 1. Now, this part is default. It may work without it. Okay? So it works the same way as removing not bringing that. So this also works. Not bringing by, just comma 1 should work, because so that should also work. So what you may want to do is to put them together and make them one table, and I can give an object name and say data.frame. That's very important. We'll talk about that. And so SN, age, and weight. Now it has to be the exact name. If I put W here, it shouldn't work because weight is not found. But the object name is weight in caps, so it has to be the same. Now it works. So normally when you have a data set, it's usually huge or large. You want to look at some parts of the data to know if you are working with the data. But if you want to look at it as a table as it is, you can use the view function, and that will bring it to you as a table. Okay. Obviously, this is short, so you can see all of that at once. Sometimes it's too big, you don't want to look at the table like that. So you may look at the head. The head will give you the first 6 rows by default. So that's the first 6. You can also choose the number of, so you can choose the number of the first rows you want to see. Maybe you can do comma, maybe 7 instead of just 6. And that happens with tail as well. So tail will be the bottom 6 data. Okay. And you can also look at the last 6 or 7. Okay, that's also fine. And if it's a typical matrix or table, if you have rows and columns, we can use them. Them is, we're going to give you the dimensions. So you have 8 rows and 3 columns. That's how the data is, 8 rows and 3 columns. Okay. So let me put a comment here. Let's take a look at your data. Okay, one more thing another thing is that you want to work with different portions of your data, so you should be able to access the data. Okay. So as a matrix, you can access them by its rows and columns. So A, comma Okay, so let's say M comma N. MA will be the row and N will be the column. Okay. So if you want to look at the first row and the first column, we know what number is there, or what number is there. First row, first column. So if you look at this table, what do you think the first row, first column entry is? What number? First row, first column, based on the table here. So we can get first row, second column, 1 comma 2. That will also come. Can we check if that's true? Then first, maybe second row, third column. That's true. What if we did first row or second row, fourth column? What do you think will happen? We are going to have an error because our data doesn't have 4 columns. It has only 3 columns. So there's nothing in that second row, fourth column. That's why. Okay. How about we want only the first row? So what we can do is that we can just select the row and leave the rest. So this is what is in the first row. We can get the same thing for second row or third row. Yeah. In the same vein, we can do that for column. So it means that the row will be empty and then we can choose first column like that. We can also do that for empty row and say third column, and that will also show. Okay. Okay. So the next thing we can do is to use the names of the objects or the columns. So if I do dollar say age, I should have all the age values in the age column showing, and do the same thing with height or weight. You realize that it has to be in double quotation because I'm referring to a particular character, that one as well. Another thing we can do is pick them out with the dollar sign. I will explain that very shortly. Then we also do that with the age. So with RStudio, you can even select. And lastly, we can do that with the height. Suppose you are working along a very long code and you don't remember all the names of the columns. You can use the names function to remind yourself of the names in the column that you are using, the column names. And here I forgot one thing, the structure of the str. So here you see it's describing to you that it's a data frame. That's the class of the data. It has 8 observations over 3 variables. And that's one thing that you can also do. All these from base R. Okay. Now let's go briefly to working with data from my directory. Let me see what is inside day one on the website. Any data, put it in my day one folder. Just okay, just a moment. Okay, so let's start with the we need to work with our working directory first. So working directory. This one I would like everybody to do this one. Directory. So the default directory you can get by using get wd. So that's get working directory. That should tell us where our working directory is, and that is usually your documents. That's usually your documents. Okay. So you need to check if your directory is in document. If it's not there, it means you have changed it. Okay, so that's mine, and we can check what is inside the directory with this command. So all these things are there. That's where I put a lot of things. So that's not where I'm going to be working from. So I need to change the working directory. Change working directory. So, and I can do that with set wd. Set working directory. And I need to give a quotation. So if you know the directory where you are going to work from, you can use the shortcut. This is not a programming class, so we will try and use some shortcuts. So we indicated that R only reads double backslashes or 1// So we need to double this, and that should work. So if we now get our working directory, let's go and run line 119. That changes us back to, that now tells us where our working directory is, which is code share day one. But we can now check the things that are in them. So in this folder, any data that is here, we can use, or when we are saving an output from R, it will go there. Okay. The other, so let me do all, depending on, so this is for Windows operating system. It's a little bit different from Mac. So those who are using Mac, you may have a little challenge there. So set wd. So I need to change the directions because R doesn't read this one. And this works fine as well, either of them. So our directory is still the same place. Okay. Now, I want to, before we get into packages, I want to load data from, I want to load only data that can be read with base R before we go into packages. So let's say read data. So two base packages, base file extensions that R can read are base extensions .csv and .txt. Those are the two base extensions. So if you have a file that is not either .csv or .txt, then we need an external package to read that, which we will get into shortly. So let me use two files that are both CSV and TST to illustrate this one. So if you have, let's say the file is AI. Okay. But CSV is command delimited. Then I'll save another one as TST so that they are not the same. TST just a moment. So that's TST is tab delimited. So when you are saving your file, you need to choose tab delimited. Okay, that's fine. So for CSV, we are going to use the function is read.csv quotation, then the name of the file. Now, if you come to directory, for example, here, you see that I have robo global ai.csv. Typically, I don't want to have the names of my objects with spacing, and this is stocks global.ai. So what I'm going to do is I just close the spaces so that reading them will be easier. But if I load again, if I check it, you see that the names have changed. Stocks global and robo global. So for the CSV, I'm going to read.csv, and that is robo global AI. .csv, we need to bring that one. That's very important. Then we need to add a new argument which says that the header, the first row of the data is headers or names. So that should work fine. And you realize that AI, but I said A1 has been loaded here. So it has 2,587 observations of two columns or variables. And now let me load the stx, the stocks, then we can look at them together. So that will be read, it's a tst file, read.table. This is a tst file, it has to be read.table. So it stocks global AI dot txt. Guess what? I forgot my quotation, right? So that will be a problem. So I need my quotation. Then header got true. So there's a problem. .txt, yes, so it's f table, it's read.table, not f. Okay. So once we have these objects or data files or tables, we can do as we did earlier. We can look at the head of A1, also look at the tail of A1, and we can look at the dimension as well. So you see that the head, the top 6, the tail, and the dimension. Can view it as a table, A1, and this is the table for us here. Okay. Okay. We can look at the names in that object. So names AI, you see that those, the date and robo AI, those are the column names. With that, we can extract, say, AI, A1 dollar, just the date. That should spit it out for us. You may usually not use it for anything, but you should have an idea of how to access your, and we can do dollar robo AI. So that's also the date. Okay. Now here, so I'm going to pause briefly. No, we will just look at the packages and we'll pause.